Alright, the last topic in our chapter 4 is about counting. In this section, we will review 5 different methods for counting problems. And because we have already learned these 5 methods in our middle school, so this section is just a quick review section. First, we will talk about 5 different methods for counting in this section. We will just focus on these 5 methods, although they actually cannot solve all of the problems, but we only need to focus on these 5 methods. First, we call it multiplication counting rule. It's not the same rule as the multiplication rule in probability. This is just the counting rule. Okay, let's talk about what's the multiplication counting rule. Since we have a sequence of events, this time we have a sequence of events. For example, we have a sequence of event A, B, C, and D. So for the first event, we have several choices. Let's say if we have in one choice. So which means the first event can happen in one ways. And for the second one, event B, can happen in 2 ways. Event C in 3 ways. And event 4 can happen 4 different ways. And if we want to know the total number of outcomes, it should be in 1 times in 2 times in 3 times in 4. This is called multiplication rule for counting. Okay? A sequence of events. The first one in 1 way, the second one in 2 ways, and so on. Then if we want to find the total number of outcomes for this sequence, we should use multiplication rule in 1 times, in 2 times, in 3 times, in 4. Let's check example. So this time, we want to guess the 4-digit passcode. 4-digit passcode, we can treat it as a sequence of events. So first event is try to guess the first number or first digit of your passcode, right? The second event can be guessing the second digit of your passcode, and so on. So we have 4 events in this sequence. And for the first event, we try to guess the first digit, but we have 10 different digits, right? From 0 to 9. Actually, we have 10 different choices. So which means the first digit, it can happen 10 different ways, right? How about the second digit? We can also choose one from 0 to 9. We still have 10 choices. And for the third digit, we can pick a number from 0 to 9, 10 choices. And the last digit, the 4th digit, we still pick a number from 0 to 9. We still have 10 different choices. So if we are interested in the total number of different possible passcode, which means we want to know the total number of outcomes of this sequence. So we use the multiplication rule. Okay, this is the total possible outcomes or total number of different passcodes, right? Then we check the second question. What is the probability guessing a code on the first attempt? So this second question is about the probability, because we already know the probability of this event is, because this time we only try once, right? The first attempt. So we only have one attempt over the total attempts, total possible outcomes. So the probability will be 1 over 10,000. Okay? If the question is just asking you the number of different passcode, then that will be 10,000. But if it's about the probability, you cannot just give me 10,000 as your result. It should be 1 over 10,000. Okay? So make sure you know the difference between the counting problem and the probability. So this slide show you the solution, right? We should use the multiplication rule. If you give me the fraction, it's okay. If you prefer to use the decimals, it's still fine. So the second rule is factorial rule. This time we want to do the arrangement. We have n different items. Here, we make sure you know the keywords. N different items. All the items are not the same. And we want to select all of them, put them in order. How many possible different arrangements? All of them will be selected. And we have this formula. That's n factorial. This exclamation mark is called a factorial. Alright, the factorial symbol. What's the meaning of this factorial symbol? It means the product of decreasing positive whole numbers. So for example, we'll talk about what is 5 factorial. 5 factorial is just 5 times 4 times 3 times 2 times 1. Decreasing positive whole numbers and do the multiplication. So it's the product of decreasing positive whole numbers. And by the special definition, the 0 factorial is equal to 1. So you can think the factorial rule is the special case of the multiplication rule. It's still the multiplication, but it's a special one because the first item or first event we have n different way. But for the second item or second event, we only have n minus 1 different way, and so on. So this time we can treat it like if the first one is n, then the second one will be n minus 2, and so on, n minus 3. So we can treat it is like this way. This is still do the multiplication, but it's a special case because there's a relationship, right? The first item is n, the second one is just n minus 1, and the third is n minus 2. So we can easily use the factorial rule to do this kind of questions. Let's still check the example to help us understand. This time we have visit the presidents of 1, 2, 3, 4, 5 companies. So we should visit all these 5 different presidents, right? So total we have 5 different items, we can say 5 different presidents. And we want to select all of them, but we want to put them in different order. How many possible outcomes? Because here we only have 5. N is equal to 5. So this kind of problem, we use factorial rule, right? So factorial, if it's 5 factorial, we can do it like this. 5 times 4 times 3 times 2 times 1. So it will be 120. If you have your calculator, you can easily get the factorial by using your calculator. Okay? Now let's check the second question. If 1 is randomly selected, what is the probability? This time we'll talk about probability. So we use the probability of this event. And the presidents are visited in order from youngest to oldest. So if the order is from youngest to oldest, that's just one of the case, right? This case is just one of the case, and this case is just youngest to oldest. And how many possible outcomes? We have 120. So it's 1 over 120. This is called a probability. 120 is just how many possible outcomes. And the probability will be just one case. This case is just from youngest to oldest, 1 over this total number of cases. So make sure you know this is probability. That one is called counting. So these are the details of solution. Okay. Next one, we will talk about permutations. It's still about arrangements. It's about arrangements. So let's check. The same items are counted separately. The most important part is the same items with different sequence are counted separately. What does that mean? Which means we have 3 same items, A, B, C. Okay, we have 3 items, A, B, C. The same items, but different sequence. So, which means I can put them in this way, A, B, C. Of course, we can put them in different sequence, A, C, B, but the same items, right? Still about A, B, C, 3 items, but in different order. Of course, I can put them in B, A, C, or B, C, A, and so on. Right? We list all of the 6 combinations here. They can be treated as 6 different permutations. They are not the same one. They are different. So for permutation, we will say, does order count? We will say yes. The order counts. Or we will say the order matters. Because even the same items, but put them in different orders, can be treated as different result. So order does matter for permutation. We have another one, which is also about arrangement. But in this arrangement, we still have same items, but this time different sequence. Will be treated as the same, which means A, B, C, A, C, B, B, A, C, all of the 6 will be treated just the same. So in this case, does order matter or does order count? We will say, no, order does not matter. They are just the same. ABC is same as ACB is same as BAC. So all of this situation can only be counted once. Will be treated as the same thing. So this page just shows you the permutation. You can use position P to help you to memorize. Position, so which means the order matters. So combination, you can pick committee. So for the members of a committee, order does not matter. They are just the same. Okay, this just help you to understand. Let's check what is the permutation rule. So n different items. Remember, we still have n different items, but this time we not pick all of them. We only select R. We want to select R of them without replacement. So we will pick R items from n items, right? We select R out of n. And the number of total outcomes, we can use this formula. So here P, capital letter P stands for permutation. Permutation. This n means how many different items in total. And this R means how many items we want to pick. And this is your formula. Make sure you don't forget we have this 2 factorial symbol. It's just not a single number, it's the factorial of number. Let's check the example. So we want to do the bet. If we could win, if we want to win, if we could correctly selecting the horses, finish first, second, and third. And you must select them in the correct order. So from here, you can get this hint. Must put them in the correct order. So this case, we will ask ourselves a question. Does order count? Does order matter? We will say yes. If we select the correct 3 horses, but put them in the wrong order, we still cannot win the prize. Only if we pick the correct 3 horses and put them in the correct order, we can win. So order does matter in this case. If order matters, we should pick permutation or combination. If you forget that, go back to check. We should pick permutation. So we write down P first to tell us order does matter. We pick permutation. Now we check how many different items in total. We will know we have total 19 different horses, right? So N will be 19. How many horses we need to pick? We already know first, second, and third. So that's 3 horses. So by the formula, there will be n factorial n minus r factorial. So in this case, it will be just like 19 factorial. So 19 minus 3 will be 16 factorial. Of course, you can directly use your calculator to help you do the calculation, but if you do not use the calculator, factorial function in your calculator, you can do it like this. Right? Because the remaining part, 16 times 15 times 14 and so on, we can just write as 16 factorial. Then the denominator is also 16 factorial. We can cancel out them. Then you only need to do this part. If you don't know how to use the factorial function in your calculator, you still can do it easily. So for this case, we got this will be the answer of our first question. How many different bets are possible? How many different bets are possible? So if we want to select three horses, put them in the correct order from 19 different horses, how many possible combinations? How many possible permutations? So the previous one is just show you the answer of the first question. Let's check the second one. If one vector selected, what is the probability? By selecting California crown and the commanding curve to be the second, and the dancer to the third. So what's the probability? So first, California crown. Second, something like that. Third, put them in the correct order. So this is just one case, right? This is just one possible bet. We just put California crown, the first, the curve, the second, and the dancer, the third. So it's just one possible bet. How many possible bets do we have? It's just... So this is the probability. So this one called the probability, 1 over this number. If we just talk about the possible outcomes, so we are doing the counting problem. So that will be the answer. But if we are talking about the probability, make sure you know it's 1 over that number. So let's just show you how can we do this question. Let's check the second permutation rule. If you check the first permutation rule, you will realize we have in different items, right? Different items, but this time it's a special case, not in different items. We will say some items are identical to each other, which means they are not in different items. Some of them are just the same. But we still want to put them in order. Still order counts. Then we use this formula. This is called the permutation with same items. So here, n is the total items we have. But here, n1 are the same, n2 are the same, and so on. Let's check the example. This time we want to design a survey. So total, we will have 10 questions. So we need to have total 10 questions. But 2 of the questions are identical to each other. And the 3 other questions are just the same. So for this kind of survey, how many different arrangements are possible? This is the first question. The second question is it critical? Is it critical? So let's check the first question. How many different arrangements are possible? So here we need to figure out what is n, right? And what is n1, n2. So we will find total, there are 10 questions in the survey, so 10 is the n. Let's check what is n1, because here we know 2 items are identical to each other, so n1 can be 2. We also have 3 other items are identical, so we have n2. 3 items are identical, 3 factorial. Do we have n3? No, because the question didn't mention we have another several things are identical to each other, so we do not have n3, we only have n1 and 2. So this is the numbers we're gonna use. 2 factorial, 3 factorial. Make sure don't drop the factorial symbol. It's not just 2 times 3, it's 2 factorial times 3 factorial. So we will get 2 factorial, it's just 2 times 1, we will get to 2, right? And for 3 factorial, it's 3 times 2 times 1, so we will get to 6. Then we can get this answer. This number tells us how many possible arrangements for this 10 question survey, right? Let's see, is that critical? It is not critical. So we need to, this number is way too high. It's not practical to get every possible permutations. So if we want to get every possible permutations, we should get such a large number of respondents, right? But actually, for a typical survey, the number of respondents is just around 1,000, so this number is too large. It's not critical. So the last rule, we call it a combination rule. Remember what's the difference between combination and permutation? It's just if the order matters or not. So for the combination rule, we still have 5 different items. Not 5, n different items. We want to select all of them. But order does not matter. So ABC will be just equal to ACB. They are just the same thing. So we cannot count them twice. All of the ABC, ACB, BCA, BAC, or CBA, CAB, they can be counted just one time as the same thing. So this is our formula. Here, C stands for the combination. N means in total different items. R means we only pick R of them. So this time, we check the lottery. The Fantasy 5 lottery game. How can we win? We only need to select 5 numbers. From 1 to 38. From 1 to 38, how many numbers do we have in total? 39, sorry. From 1 to 39, we have 39 choices, right? And the same 5 numbers must be drawn in the lottery. The winning numbers can be drawn in any order. So the question already tells you, order does not make a difference. The order does not make a difference. So same items with different order can be treated as the same. We call this problem order does not matter. Right? They are just the same, so it does not matter. First question, how many different tickets are possible? And the second question is, 1 ticket is purchased. What's the probability of winning? So let's first check the first question. How many different tickets? So the first question is a counting problem. How many different outcomes? Right? So we already know this problem, for this problem, order does not matter, which means we should pick combination. For combination, order does not matter. So for this case, combination. So we write down C to tell us we should use combination. But what is the N here? What is the N here? N should be how many different items in total. Just like I said, from 1 to 39, there were 39 different numbers. 39 different items, so that will be 39. Right? How many numbers do we need to pick? 5. So R is equal to 5. Then we can use the formula. It will be n factorial, so here it will be 39 factorial. Divided by the 39 minus 5 factorial. That's n minus r. That will be 34 factorial. But we also have another term. Will be r factorial. So in this case, it's 5 factorial. So that's the formula. We can check it. That's the formula. So you can use your calculator to do this kind of questions. I know some calculator can directly get the answer of this combination. So when you input this 1, you can automatically get this answer. So that's good, right? So if you don't know how to use this, you can list the formula like this one, then do your calculation. So for this part 39, you can treat it like 39 times 38 times 37 and 36, 35, and 34 factorial, because I will just stop here. Since the denominator also have 34, then we can cancel out. Now you can only need to do 39 times 38 times 37, 36, 35 divided by this 5 factorial. 5 factorial is just divided by this 2. So that will be 120, right? It's still possible to get the answer. Of course, if you prefer to use the calculator, the combination function to get this one, it's also fine. So for the first question, we get this as our answer, right? We have total this number possible tickets. But if we just pick one, this time we only pick one, what's the probability of winning? Let's check if we only buy one ticket. What's the probability of winning? That will be this one, 1 over the large number. So this second part is talk about probability. So we realize this probability is very small, right? This probability is very small. So we will say the lottery is a tax on people are bad at math, because it's almost impossible to happen. Very unlikely to happen.